Hello gentlemen, welcome back. Hopefully you found the calculator video helpful. This video is going to concentrate on average rate of change and then talk a little bit about parent functions at the end. So let's get this started. Let's talk about average rate of change. Average rate of change is equal to the slope of a secant line. Okay, and I guess we need to talk about what is a secant line. Well, a secant line is basically a line that connects 2 points on a curve. So here's a curve, f of x, this tan colored curve, and I have 2 points. I have one here, f of b, and I have one here, f of a. And basically all I'm looking to do is to find the slope of that line. So again, a secant line is a line that connects 2 points on a curve. And this equation right here is just our slope rise over run equation right there. Okay, where my rise is going to be f of b minus f of a, and my run is going to be b minus a. So when we start talking about the average rate of change of a function, we're just looking for the slope of the secant line between those 2 points. Okay, in order to find average rate of change, I always need to have 2 points. Let's do an example. Find the average rate of change of x squared plus 12x minus 4 between 1 and 5. So again, using my average rate of change equation, I can see that my average rate is going to be equal to f of 5 minus f of 1 over 5 minus 1. Okay? Again, this is my rise. This is just the equation of the slope of a line. Okay? If I plug in, I get 81 minus 9 over 4, which is equal to 18. If I look at it graphically, what this looks like is this. Here is the red curve here is the curve, is the function. Here's the secant line, and the slope of this line right here was equal to 18, which was my average rate. Okay, slope of the secant is equal to average rate of change. Let's do one where it puts it in context, a little bit. The number of foreign students in thousands enrolled in colleges from 1992 to 2002 is given by this function. Okay, where t is represented, t represents the years, and t equals 2 corresponds to 1982. So here's the model that we're given. And what we want to do is find the average rate of change here. Okay, so again, we can find the average rate of change, slope of the line, that's easy. F of 12 minus f of 2 over 12 minus 2. No big deal. And I can trust that you guys can do all the calculations. But the average rate is going to be equal to 14.73 thousand. Remember that this is in thousands students per year. Well, what does that mean? Basically what it means is that on average, the number of foreign students enrolling in college increased at a rate of about 14,730 students per year every year since 1992. Okay, so that's what the average rate is going to say, the average over a specific time period. Some years it would have been a little bit greater than that. Some years it's probably a little bit less than that. But on average, 14,730 foreign students more every year enrolled in college. Okay, let's look at that graphically. Here it is. Here's the function. This function relates the number of foreign students that are enrolling in college. This slope of the secant line, okay, is equal to the average rate of change. Okay, it's basically how did I get from here to here if I did it on equal increments. So if I did every year, I went up 14.73, I would end up at that point. Okay, so that's average rate of change. The other topic that we need to discuss quickly is just the library parent functions. And I need you guys to understand these functions and understand what they look like and what their domain and what their range is. And you need to study those. It's going to be very important as we move forward, especially into the next section on transformations. Basically, what I want you guys to know is what each of these functions looks like, and I want you to be able to identify the domain and range of each. Okay? For example, if I look at this cube function here, I'll note that the domain here is all real numbers. I look at the range, again, all real numbers. There's no restrictions here. But if I look at the square root function over here, I want to know that the domain here is that x is greater than or equal to 0. I can't have negative numbers. I also want to know that my range is y is greater than or equal to 0. Okay, so I need to know that, and I need to know the general shape. All right, I want you to know that if this one in this inverse function here, that is not defined at x equals 0, because again we get division by 0. So the domain is all real numbers except x is equal to 0. So take a look at these. Be able to identify domain and range. Maybe make some flashcards on these so that you understand if I'm looking at x squared, fx equals x squared, my domain is all real numbers, but my range is y is greater than or equal to 0. So please take some time, learn these, identify them, which will save you a lot of time when we get to the next section. Here are some practice problems. These two examples up here have to do with average rate of change, as do these two problems here. Read 1.6, and again, make sure you understand what the graphs, especially domain and range. Here's a few problems to practice. Okay. Again, email me any questions or concerns, and let's get ready to do the section on transformations, which really builds upon these parent functions in 1.6. Okay, gentlemen, have a nice day.